Recording in progress.
All right, welcome to Marine Amateur Radio Club. We're going to talk tonight about the AREDN interface, and we're going to talk about some of the more advanced settings that you may not be familiar with. Now, a lot of this stuff is poorly documented. A lot of this stuff is moderately well documented, and some very small amount of this is well documented. So you're going to have to kind of take it with a grain of salt when you get into this interface. It's not too hard to figure out once you actually get into it and start playing with it. Okay. So don't panic the first time you see this interface. Um, I know the first time I saw the new interface, I was like, wow, this is amazing compared to the old interface, which was amazingly bad. But with that said, these guys have been working on this new interface for over a year to try to get it modernized and reactive and working in a way that is commensurate with normal um, web applications today, as opposed to web applications in the 1980s when the internet was young. Okay, so what I've got here, this is my HAP at home. So it's my HAP at my QTH. And just to give you a little bit of background on this, I bought this node probably about a year and a half ago, and I haven't done a lot with it. But in the last 6 months, I've been doing a lot more with it and trying to play with it more and understand it more. And what we've got going now, I have this node at home, and attached to it via a cable, I have a LDF5, which is a MikroTik device that bolts onto a DirecTV dish, except that the last windstorm knocked it down and broke the mount. So I have to get a new mount for that. Um, with that dish, if I stood outside and held it in my hands about 5 feet away from my fence, I could hit Chris's node at his house with the RF. But if I put it down or I moved it or put it back where it was on the fence, I couldn't reach him at all. So we still have to figure out how we're going to sight these things, how we're going to aim them, and how we're going to make these things actually work on RF. So that's going to be a bit of a process. And we'll talk more about that next month. But for now, I wanted to kind of dive in here. The other thing that I have at home, I have a Ubiquiti light beam at home. And I actually have that sitting in my family room right now with my Yaesu or my Yealink phone attached to it, and it's pointed north, so it can hit the LDF5 outside, and I can see it and get to it over RF. So I do from my HAP, I go to the LDF5, and then from there over RF, I can come back to the LB1. I don't have any RF running on the HAP right now, but we'll look at the settings for that and we'll talk about that. Okay, so when you first bring up a node, the first thing you're going to see is a display that looks like this. And when you initially create the node and you set up the software and everything on it for the first time, you're going to give it a node name, and that's what is up here in this corner. And the rule is it needs to start with your call sign, and it's supposed to be in all uppercase. Okay, and then anything that you want after your call sign, these things can be like 63 characters long. So you can put in designators that say what kind of hardware it is. People have put in things like which direction it's pointing, what band it's on, all that kind of information. Personally, I think that's possibly overkill to put in the node name. Fortunately, you don't have to type the node name very often, but if you ever do, it's kind of annoying to have to type a really, really long node name. So I use this description field here to put the node name in. So the first thing you're going to see, let me log out so you see it, how it looks when you first connect to it. Theoretically, my tunnel's going to continue to work. Let's see, are we working? Looks like we should be working. Let's see if we can log out here. There we go. So you'll see it'll look like this. And you'll notice that I can look on here I can scroll over stuff. Nothing is changing color because I can't edit any of those things. I can, if I see under local services here, I have mesh chat running on this node. And so that is actually a link. You see how it heats up when I mouse over it. If I click on that, I'll actually bring up mesh chat. Well, I would if it was going to work correctly, but let me see if I can change this to this. Well, apparently that's not going to work. Unfortunately, that is not going to function for us. If I could get the tunnel working, things would be much cooler. But basically, if I was to click on this, I would get a mesh chat interface that I could use to send messages to other people running mesh chat. And I can do that from this node, and from their node, I can mesh chat back to myself. So I could conceivably have two mesh chats running in two different windows on two different nodes, and what I enter in one ends up on the other one, and you can see how that works. Unfortunately, I can't demo that because I can't get my tunnel to work correctly, but we'll play with that, and maybe I can demo that another time. Um, Under here, you would see local devices. This would be anything that's attached physically to this machine. That would be like if I had an IP phone plugged in or a PC of some kind plugged into the wireless or the wired network on the device, or if I was accessing it from the local Wi-Fi, those devices would show up here as well. And then a little bit further down, you see where it says local nodes and neighborhood nodes. So local nodes are nodes that are directly connected to this node. And so you can see KD7ZWV-1, that's my LDF5, and he is directly connected using a DTD connection, which is a physical cable. So there's a cable that goes from this node out to my LDF5 outside, and it's running PoE over that cable and powering the LDF5 from that cable. On here, you also can see neighborhood nodes. These are nodes that are not directly connected to this node, but nodes that I can reach from this node. Okay. So you can see I have a tunnel open to AC7BA HAP0, and we'll talk more about tunnels in a second. But over here, you can see the link quality. And of course, this is a wired connection, and this is a tunnel connection. So it's essentially going over the internet. And they're both, of course, showing up as 100%. Now, you're not seeing my LB1 on here because apparently it's decided that the rain is probably fogging it out or something. Yes.
If I'm have an antenna attached to the HAP, which one am I talking?
So when you say you have an antenna, do you mean you have a node? Yeah, so that's actually a node. Okay. So if you're connected to the HAP, you'll be talking to the node. And that device would be like my LDF5, a separate node on the network. Okay. Now, there are nodes you can get that don't have an antenna. In fact, there are some that have an integrated antenna like this one, right? That has an integrated antenna on it. But you can also get the antenna part of this as a separate device and connect that with a cable to a node that does not have an antenna on it, but has the radio in it. Okay. So that's a separate thing. And that's why I want to distinguish between an antenna and a node. A lot of the nodes are going to have an integrated antenna. Some of them do not. Okay. So that's something to think about when you're looking at hardware. What you're going to see on this interface is the nodes, not the antennas that are attached to them. Okay. And again, if my tunnel had been working, I would have been able to click on this and we could have gone and looked at his neighborhood nodes and seen what else was out there. We're going to look at that in another way in a minute here. But the other thing that you'll see on here is that this node has a radio on it, and it's a MikroTik router board 952 UI 5AC2ND HAP AC Lite. And that's the device that I'm on. Okay. This is my HAP at home. And I have it set up with a LAN hotspot on channel 149. So this is on the 5 gigahertz band. And you can see that it's set up with channel 149, and the SSID is KD7ZWV AREDN. And what that means is when I'm at home, I can go on my computer and I can say, well, don't connect to, let's see, let me drag this over. I can say, don't connect to my home network, but instead connect to, and that KD7ZWV AREDN will show up on this list. And I can connect directly to it
Is there a
on,
reason why you're using 149 here and
this is not a mesh connection. This is a LAN connection, okay? I'm not running a mesh connection on this node. We can fiddle with that while we're here. So then this section here shows the state of the mesh as it's currently constituted. So there are 16 nodes that I can reach through the mesh. Now those are mostly through that tunnel, okay? But there are 16 nodes and 24 devices and 14 services out there on the mesh that are reachable. We're going to look a little bit at some of those in a second because there's another way to see them other than this status page. On my LAN connection, I'm running a DHCP server. I've given it a /28 network, and it will issue addresses to hosts that connect to that LAN, whether they're plugged directly into the HAP's Ethernet jacks, or if I get on that Wi-Fi network, that KD7ZWV AREDN Wi-Fi network, I would end up on this network. So the node is issuing IP addresses using DHCP on that LAN, on that network. And you can see that right now there are no active leases. There's nothing out there that's connected on that. And you're thinking, well, wait, isn't your LDF5 node connected to that? That's not showing up on the LAN because that is a separate, what they call a DTD, device to device link. And it actually runs on a different VLAN. So those ports on the HAP can support multiple VLANs. And VLANs are like virtual LANs. I think we've talked about that a little bit before, maybe on the mailing list. But the basic concept is a single Ethernet jack on the machine can have multiple networks connected to it. And those networks are tagged with a VLAN identifier that says which network those packets go to, okay? And you can also have untagged traffic on those ports, and that can go to a specific network. So in this case, untagged traffic goes to this LAN DHCP network here, whereas DTD traffic goes only to the DTD interface. And then WAN traffic goes out to my home router, okay? Wide area network traffic. Yeah.
It's the difference between 28, I see there, and 29.
So this 28 here?
Yeah.
Okay, so the difference is the number of bits in the network. So let me show you how this works. So this is a little program that I wrote. Can everybody see that? It's kind of hard to see. But the idea is when you're looking at a network, and let's look at this particular address here. So I'm going to put in 10.225.133.177. Okay. And so you'll see what happens here is, and sorry, I can't make this any bigger. I wrote this program about 20 years ago, and it's pretty rough. So, you get what you get. But there are subnet calculators on the web, but I don't want to try pulling one of those up right now while I'm trying to get all this other weird networking stuff to go. But what you can see is that this is a Class A network. So normally it's going to have an 8-bit subnet mask. And so this part is the network part, and this part over here is the host part. And you have the subnet mask here. Don't worry about what a Cisco mask is. You're not going to care about that. This is the network in hex. And then it says there's one subnet with 1.6 million hosts per net, or whatever that is, 16 million hosts actually able to be on that network. And then here you can see the network is net 10. This is the broadcast address, and the valid hosts go from 10.0.0.1 to 10.255.255.254. So what you can do is you can subnet down this number, this network. And if you take it down to 29, which is what your 29 would be on your device, you will see that what I end up with is a whole gob of possible subnets with 6 hosts per net. Now, one of those hosts is going to be the device itself, and the other 5 are available for other things that you want to put on that network. Let me just bring this down so it's a little cleaner and you're not seeing a whole jillion things here. This is what we call CIDR routing, okay? So you actually set the subnet mask to 29, and what you're saying is, I'm going to mask off all of these bits as the network part and only use these last 3 bits as the host part, okay? So you get 6 hosts per net. In the AREDN interface, it says you're getting 5 because 1 is reserved for the host itself. Okay. So I have mine set up as a /28. Let me just pull these both back to 28. And you'll see I can have 14 hosts on my LAN. One of them is reserved for the host itself. And the AREDN interface will say 13 hosts on this network. Okay. The interface allows you to choose either 5 nodes, 5 hosts, 13 hosts, or whatever this next one is, which is 30, right? And then I don't remember if it gives you the option to do one more or not. It calculates what this network is and what these addresses are going to be based on the MAC address of the device itself. So these are global within the entire mesh based on your device. Okay. And if I was to change this from the /28 to the /29 or the /27, I would get a different address here, a completely different address here, because it's that network is going to be in a completely different place where it ends up. Okay. So that's something to think about. How many hosts do you want to have on your LAN at home? And my HAP only has 3 Ethernet ports left on it that I can plug things into. But because I can do the Wi-Fi connections to it, I might connect to it with my laptop. I might connect to it with my phone. I have a work laptop I might connect to it with. I might connect to it with something else, right? A tablet, or who knows what I might connect to it with. So I wanted to reserve a few extra addresses to play with, just so that I wasn't locked into only having 5 hosts on that network. It's fine to have the 5 if you're not plugging a bunch of stuff into it. Even if you're, if you're plugging 5 things in, you're good. You've got all 5, you've got them. So that's something to consider, though, is how many devices do you want to put on your LAN? Okay. Because remember, anything that's on this LAN can access anything on the mesh. Okay. It's just like a regular mesh host. All the mesh hosts are on this net 10, and they can access anything else that's out there, with some caveats, which we'll talk about. And then the last section on here is this tunnel section. And you can see I have one allocated client tunnel that is active. That's my tunnel to Sam's machine. And then I have one allocated server that is not active. And that's the connection that I was trying to get to go from my laptop to my node at home, which I have not been able to get to work successfully. So over here on this side, again, I've got the description. I've got the time. This is what time the node thinks it is, and it thinks it's 6:48. So it obviously hasn't figured out that it's daylight savings time yet, because it's actually 7:02 really. Actually, this may just need to be refreshed. Let's see if we can refresh it. Yeah, it's got the right time. Okay. And it's been up. This node has been up for 4 days, 19 hours, and 19 minutes. If I was to reboot this, this would go back to 0:00. Okay. And then here you can see the load average of the machine. This basically tells you how busy this node thinks it is. Okay. These numbers are a 1-minute average, a 5-minute average, and a 15-minute average of the number of processes that are ready to run. The only resource they need is the CPU to do so. So if it's waiting or blocked on IO, it doesn't count in this list. But if it's just waiting for the CPU, it'll count in this list.
You get your time updated.
I just refreshed the screen. I refreshed my connection. The page.
Don't you have to tell it what your NTP server is?
We're going to talk about that. And so the other thing over here is the free flash and free RAM on my device. There's been some discussion on the AREDN Slack server about changing what free means over here, because what this is showing you right now is actual unallocated memory on the device. Now, there's also memory that's assigned to be used in the buffer cache, which is used to buffer IO to the storage. And that memory can be used immediately if it's ever needed, but it doesn't show up as free memory. Now, what the kernel tries to do is keep the free memory as low as possible by leaving things in this buffer cache on a least recently used basis to ensure that if it needs to use something, if it's already in memory, it doesn't have to go back to storage and get it, right? So they're talking about changing that to show the actual free memory plus the buffer cache, because that's really how much memory is available to do stuff with. But then you've got to keep in mind, I don't want to use up all of my free memory for things because then I won't have any for buffer cache and that will slow down all of my storage accessing. Okay, so there's some discussion happening about it. And then down here you'll see the AREDN version. So this guy is on 3.25.20 and he's up to date. This won't show up if you don't have a connection to the network, to the WAN, to the internet. Okay, because it won't know. It won't have a way to find out if there's a new version out there. But this is the firmware version, and then if there are any issues or release notes, there are links here that will take you to the GitHub page for the software where you can look at the issues, which are like bugs that people have reported. And the release notes will take you to the documentation so you can see what changed in this version of the code. Okay. You have to have internet activity or connectivity to access these two links, right? And then down here is the network. This is the mesh address for the node itself. And you'll notice this is a /32, which basically says I'm going to use the entire number as my network. Well, it's really using it as just a reference for this host. But because of the way the mesh networking works, this actually works correctly. Its LAN address is 10.225.133, which we already saw over here. The WAN address, this is its address on my home network at home. So it's on 192.168.50.193, and my home network is a /24. So that means I can have 253 hosts on that network. My WAN gateway is 192.168.50.1. That's my home router that's connected to the internet. And then I have WAN DNS here. I've said you can use my home router for DNS, or you can use this 8844, which is a Google sponsored DNS that it can use if it can't resolve it on the home LAN. Okay. And then the last thing on this side is a map which shows you where this node is located. So it's always going to be right in the middle of the picture unless you've moved it around. And you can actually grab this and go into this as a view. And I don't know if that's going to actually work through this interface. We'll look at another way to get at that information in a minute. That's basically this main interface. Over here on this side, there's a few other things that you'll see. This interface is the little I. So it's just the info. That's the page, info page for the node. It's done with your EMP training.
Yes,
All
sir.
right. Thanks for giving us the room. We appreciate it. So if you're ever stuck and you're wondering where you're at, just hit this little I and it'll bring you back to this page. This one is a description of what's out there on the local mesh. Now, remember we said there were a bunch of nodes that I could see and some devices and some services. So if I go into here, I can actually see everything that's on the mesh that I can get to. Okay. So here's me and my mesh chat service. This is my LDF5 over here. No services running on it. You can see, let's see if I can scroll this. I have excellent connectivity to my node. My node can talk to itself. That's great. And it can talk to the one that it's directly connected to by wire, which I expect that to work. I have good connectivity to Sam's node over here, AC7BA HAP0. That's the guy that my tunnel goes to. And he's running a mesh chat and web.local.mesh, which I can't show you because I don't have a fully functioning tunnel. I also have good connectivity to his super node, which this node actually connects to this node. And from there, you can go out to like California, Phoenix. There's a few other places that are tied into that super node network. Yes,
Can you
Ragnar.
actually see
Yes.
that on a map?
Yeah, you can. Yeah. So
That would be cool.
I can't show you that unfortunately because I don't have that tunnel working, but yes, you can. And then there's also this AC7BA LHG5-0, which is another node at Sam's house that's pointed at Chris's house. Okay. And then I have fair connectivity to these guys. So N7KRJ, he's got a node with a phone attached to it and a mesh chat running. KK7ZJN, that's Chris. He's got an HAP and an LHG5 and another LHG5. And then Russ over here, I can see your R3 node, whatever that is, router board 3. And then I've got W7PKA. He's got an HAP light that's running. It's got a Raspberry Pi hooked up to it. And so he's got some things on there that if the tunnel was working correctly, I could actually click in here and go to these web pages and see those, which unfortunately I can't do. This is Sam's also. This is his node on his RV, and he actually has his solar controller on here. And I could conceivably click on this and go fiddle with his solar controller or see what it's doing, see what it's reporting as far as how much solar power he's seeing. So
Now you may want to.
he may want to turn that off, or he may want to rename it something other than solar controller because that's its host name on the entire mesh is solar controller. Okay. And then he's also got a node red, but he doesn't have a link to that. He doesn't have an address for that. So I don't know. I can't reach that. And then down here in slow, you'll see on here, there's some more things that I could reach. And when it says slow, it means slow in terms of mesh networking. So it's not like 300 baud slow. It's like, I'm still on the internet slow, but maybe I'm accessing a machine in Japan instead of a machine that's local to me, right? So even though it says it's slow, it's really not that slow. And W7PKA has a camera, and I was just looking at that earlier today when I was connected to my node. And I can see from his front door basically out to his neighbors across the street. So I can see that from this interface just by clicking on this, or I would be able to if my tunnel was working. And then there's a couple other nodes over here that are also out there. But you can see these are basically the nodes that are out on the local mesh and the services and devices that are out there. If I click on this one, this is going to show me, well, it would show me the super node, which would be that map that we were talking about. But again, I don't have connectivity to that without the tunnel. So unfortunately, I can't show that. But that is going to actually show you all of the things you can reach everywhere that's connected to the super node. So stuff in LA, stuff in San Francisco, stuff in Phoenix, other stuff that's out there. So it's kind of cool.
Isn't there a way on Packet you could do the same thing?
You could do similar things on Packet, but a lot slower. So yeah.
Of course.
But yeah, Packet had the ability to route packets between nodes and stuff. Packet's actually pretty cool technology, and a lot of people are getting back into it now. So it's certainly something that's worth playing around with, and it still works. It's still very effective. So, I certainly encourage you to break out your old Packet gear if you've got some and see what you can talk to. I know some people have BBSs running, and there's other stuff out there. along the same regard, there's people running Meshtastic now, and there's a BBS on Meshtastic that you can reach and do stuff with that I haven't been able to successfully reach it yet, but theoretically I could do that if I had a better sighting for my
There's
Meshtastic
some
node.
local.
Yeah.
that are-
Yeah. And then this last one is the world map here, which again is going to show you if it works. So here you can see my node, and I'm connected via tunnel. That's this dashed line to Sam's node over here. And so is Chris here. There would be a solid line here if I had an RF link to Chris's node. This is where Chris lives. But you can see there's quite a few people that have brought up tunnels into Sam's network. We can actually zoom this out a little bit and see where all these tunnels go. And as we back out of Salt Lake, you'll see that there's all kinds of stuff out here. And when I'm on the mesh with these tunnels up, I can reach any of these sites. So if some guy in Houston has a camera watching a flood or something, I could go to his camera and watch it live. Same thing with any of this stuff out here or this stuff over here. I can go there. If I had my phone hooked up and working, and they had a phone and I had their IP address, I could call them directly from my phone to their phone using a VoIP connection directly over the network. So pretty slick. This is all dependent on the tunnels, which, a lot of these things are going to be connected via RF, but you can see with the tunnel capability, as long as the internet is up, we have a pretty wide area that we can work with and play with and talk to and understand how different things work. So hopefully we can do some of this stuff next time, not next time, the next time after that, when we'll be talking about different applications that are on the mesh. Hopefully I have my tunnel working by then. So
I see on the nodes listed that you've got 1372 no RF out of a total of 3,000.
yeah. Yeah, so there's 1,372 nodes that are not connected with RF. There are 62 super nodes. So think of the super node as like you've got your local mesh, and then there's a super node that's a layer above that. And he talks to other super nodes around different places using the same mesh communications technology as your local mesh. And then each of those super nodes are tied into their local meshes wherever they happen to be. And so from my house, I can connect to Sam's supernode and then go to the supernode in LA, for example, and then drop down into the LA local mesh and access services that are running there. So pretty cool.
Does it sort of run like in Las Vegas? They
Um,
have the
Does it look
like the DMR stuff?
Yeah, there's some
Is it
stuff
local?
here in Vegas. I don't know what's going on in there in Vegas. Looks like some no RF stuff happening in Vegas. So just tunnels. What was the question though? You about
But it was similar to what's it called? In Vegas, they connected in DMR, and then you would connect to
like a hub,
like a hub,
like a repeater or whatever they call it, a reflector.
reflector.
A reflector.
That's the word.
Yeah, so each of these nodes is essentially a reflector.
That's
Right.
what I.
So if you can connect to a node and it's connected to another node, you can connect to that node. You can go through this mesh network and go directly to it and send traffic back and forth.
So would there be an advantage to local nodes to connect to the super node instead of trying to connect
The
several nodes?
the advantage is it's easy to get it to work, and
Oh, okay.
and you can do it readily, right? The disadvantage is if the internet goes down, all of your tunnels are gone. So you need to have that RF functionality for any time that the internet is down, and you need to be able to access stuff locally.
Yeah.
And theoretically, we've talked about doing a long haul RF link down to St. George and tying into them through RF with some mountaintop nodes along the way. So I don't know if or when that's likely to happen, but that's something that we could do and have an actual RF connection into St. George And because of the way the mesh protocol works, if we had a tunnel to St. George, normally our traffic would go over the tunnel just fine. But if the tunnel ever disappeared for some reason, like the internet broke, all of a sudden that traffic would automatically reroute to go over the RF network. And so as long as you've got the RF network in place, it'll be functional. So
That's actually very cool.
yeah. Okay, so let's see. So the next thing to show here. Oh, one of the cool things about this interface, let me just go back into this view. And you see this help button. Anywhere that you see a help button, you can click that and you'll get context relevant help right on the page that tells you what's going on. So there's a little description here that says this is other nodes on the network, as well as what servers and services they provide. Okay. If you don't need it, you can click the button, turn it back off again. Let's go ahead and log into the node. So this little guy over here, when he looks like this, I'm logged out. And if I was to go to Sam's node, I don't have his password, so I can't log into his node. But anything that I've been doing so far, I could do on his node, not logged in, because all the stuff that I've shown you so far has been without being logged in. Okay. But if I want to make changes to my configuration or anything like that, I want to go in here and log into my node. And it's going to ask me for a password, which I happen to know. And now you'll see the little icon has changed to this dude in the circle. And the rest of the interface looks pretty much the same, except when I mouse over things now, you'll see that they kind of highlight. And that means that I can actually click on those and change them. Okay. And you also get this little toolbox guy down here, the wrench and screwdriver icon. And we'll look at that in a sec. But let's go ahead and look at some of these things. So if I was to go in here and I wanted to change the description of my node, I just click on that. And you can see this pops up, and I have a nice little interface here where I could change my node name. I could add -HAP in there, for example, and that would suddenly be part of the node name. I could change the description. I can change my notes about the node. I can change the theme for the interface, and there are a few different themes, including a high contrast theme, a light and dark theme, and a theme that's supposedly good for people who are colorblind, which I'm a little bit colorblind, but not enough to be legally colorblind. But I found that the default interface looks just fine. I can change the password for my node, and then again, if I turn on the help, all of these things have descriptive text that tell me what that means. So I don't have to know if the first time I'm getting in here and I'm like, what in the world is this talking about? I can click on help and I can see, oh, that's what this is. Private notes about this node are only visible to the operator. This can be anything thoughtful, relevant, or useful. For example, I could put custom configuration info or attach device information notes in here. It's not going to be sent out on the mesh, okay? Whereas my descriptive text about the node, this is sent out on the mesh. And so other people will be able to see that without coming directly to my node, okay? The next thing on here is this advanced options section. So some of these will have advanced options. And if you click on that, it will open up a new advanced options section. And for this particular part, I can upload an SSH key. SSH is a protocol, a secure shell protocol, which is used to log in as a terminal to the node. Okay. If I want to do that for some reason, I can do that. When you do that, you're going to get something that looks like this. Let's see. Did not like that host name. Let's try that. Yes. And I'm now logged into my node, and I've got a terminal. I can run terminal commands. I can do, change settings or whatever that I want to do from in here. Unless you know Linux, you probably don't want to mess with that. Okay. But you do have the ability to do that. And normally I would need a password to do that. But because I have uploaded my SSH key, which is right here, I can just log in without having to use a password. I can upload additional SSH keys and they'll show up in this list. I can remove them by clicking on this and it'll take it out of the list. Okay. If I change my key or something. And then after I make a change, if I browse to a key file and put it in here, or if I remove it, select it to remove here, I have to actually click this to make it happen. So if I was to put in a new key file, I'm going to upload that key, or if I select one to remove, I would be removing that key. These things happen immediately when you do them. So that's different from a lot of other things. I'm not going to do that right now because I don't want to take my key off of there. But the other thing that you will note is I made this change to the notes. If I say done, it's not actually there yet, but it's popped up this pending changes box. And at this point, I can choose to either throw my changes away or commit them to the running interface. Okay. Used to be if you made any change anywhere in the old configuration tool, it'd reboot the node. It doesn't have to do that now for most things. Some things it still will need to reboot the node. Like if you change what a network is going to do, it'll reboot the node. But you still have to commit it through this mechanism first. So if I hit commit here, it'll go out and do that. And you see this little spinny dialog here. Now it says quiet little box over here under notes. So it's kind of cool. The time, let's go ahead and pull that up. So here I can specify my time zone, and it's got a list of known time zones. I don't think Zulu time is in here, which I find annoying. But I happen to know that Iceland runs on Zulu time. So if you want to put your node in Zulu time, just select Europe.
Isn't there under UTC?
Did I have a UTC? I don't think I have that.
Okay.
If it had that, that would be great. But yeah, it doesn't have that. But if you select, what is it, Reykjavik in Europe? Well, it's not on here either. Apparently you can't select that on this one. I'd have to hunt around for another zone that doesn't do daylight savings time. And then here you can specify an NTP server. Now, at some point, we're going to put NTP servers on the mesh, and you'll be able to put a mesh name in here for the NTP server. And you won't need a WAN connection on your node for it to be able to access things. But for right now, I have it set to use us.pool.ntp.org, which resolves to a list of different NTP servers that are available to use out on the network. There's also a secondary time.cloudflare.com. So if it can't reach this guy, it'll try this guy. Okay. And then this just says, go ahead and re-update that every day. Now you can also run an NTP server on your node, in which case this won't be here. And what it'll do is it'll actually maintain the time correctly. And I know Jeff has a node that has a USB port on it, and he has a GPS plugged into that USB port, and his node can act as an NTP server directly. Unfortunately, you're not on the tunnel yet, so you can't get at it that way.
Yeah, you can just flash it.
And then here you can say, do I want it in 24-hour time or 12-hour time? I can change that here. And then advanced options for this, I can say use GPS time if I have a GPS. Okay, so it'll actually do that automatically without me having to do anything weird. That functionality is built in. I'm going to go ahead and cancel. I don't think I made any changes, but there's no point in having to revert those changes if I didn't make any. You'll see that this part doesn't highlight because there's nothing to click in here. I can't change any of these values. These are just informational values generated by the system. This one, the firmware, I can go in here and I can upgrade the firmware if I want to. And since I'm connected to the WAN, I can actually pull down a list of available firmwares for this device, and they will show up in here. These are all the different versions that I could put on this box. This is the one I've got right now, 325.20, which is the current release, or I could choose this and switch to nightly releases if I wanted to. And then what it'll do is it'll actually fetch an upgrade will become active, and I can download that and reboot into that new version. I'm not going to do that. If your node is not connected to the WAN, but you have a firmware file on your laptop, for example, you can upload it here and send it directly from your laptop to the node. So nodes that don't have WAN access can still get updated through this mechanism. It's not as automatic as the other way, but it's still available. Let's see. I can back up the current configuration. Basically, that's going to produce a file that I download to my computer, and then I could re-upload that configuration. So anything that I've specified, like my node text or my descriptive text or anything like that, if I was to reboot this machine or re-wipe it and start over from scratch, I could take my saved configuration and load onto it without having to go in and make all the changes again manually. And then the advanced options, I can set it to keep configuration after an upgrade, which normally I want to do. If I turn this off and I do the upgrade, it'll be like it was brand new out of the box and I just first flashed it with the AREDN software. So on that first boot, it'll come up and want me to enter a node name and go from there. So I'm not normally going to do that, but there may be some conditions where a node becomes confused and you need to reset it to a known state. You can do that. And then dangerous upgrade says force the firmware onto the device, even if it fails the safety checks. And if I turn that on, I could use that to like reflash back to the original MikroTik firmware if I wanted to. It's not AREDN firmware, so it doesn't want to load that on there for me, but I can force it to do that. So I don't have to take extraordinary measures. I just have to go turn this on. And then a firmware URL here, I can actually change this. If we have a server on the mesh that has a copy of all the AREDN firmware on it, I can put the URL to that server in here. And I think somebody has one of those. We saw it when we were looking at the network services, the mesh services. I don't remember which one it was, but one of them had an AREDN source download or our AREDN repository on it. And so without having WAN access, I could still update over the mesh if I change this URL. I'd have to know what that is though, and that's why it's under the advanced settings. Okay. This shows installed programs. I have 3 packages installed on this device. Let's pull this in. So packages are like extra software that's not part of the AREDN release, but it runs on the node or can run on the node. So if I want to look at what packages are known out there, I can refresh this because I have WAN access. I could also do this if I had that download firmware link filled in and I had a node on my mesh that had this stuff. I can still do that, right? And then I can see a list of all the different packages that I could put on here. So probably the only one that I really care about is this TCP dump. I want that so that I can debug what's going on with my attempt to tunnel into this thing from my laptop. So I'm going to go ahead and install that right now. And you'll see it tells me a little bit about it. It's package TCP dump mini. It depends on libc and libpcap1. It'll automatically grab those if it can. So I don't have to worry about that. It's not installed. This is the architecture that it's for, which is defaults to what the node is that I'm running. And then it shows the size. what is that, 140K-ish? And then the name of the package and a little description of what it does. So if I do that, and then I come down here and I say fetch and install, it'll go out and grab that package, theoretically. We'll see. Maybe it will. There it goes. And it'll install it. And if I want to know what packages I have on my machine, I can click on this and I can see what's on here. So you can see I already have a couple of things here. There's the lib PCAP that it said it needed. I didn't have that before. Now I do. There's this Lucy lib base and lib Lucy HTTP Lua. Those are needed by mesh chat. The mesh chat is on here. And now the TCP dump mini is on here. It said that it needed libc. Libc is already there. So I don't need to worry about it. You can't remove libc or the whole machine would stop working. So I could go in here and I could remove one or more of these packages through this interface as well. If I was to do that, it would change this to remove. And if I click that, it would take it off of the machine. I'm not going to do that. But now that I've put that on there, if I go back to my terminal where I was logged in here, and I can run TCP dump. Look at that. That wasn't there before. It was not part of the base operating system. But I just installed that software and put it on there. I can also upload a package, like I said, from my local machine, just like I could upload a firmware for my local machine. There's a ton of stuff on here that you can put on. There's the GPSD. There's a bunch of kernel modules for different things. If you need them, you can install them. If you don't know that you need them, you probably don't. But there's different tools on here to do different things. And there's also tools that are not on here, that are not on the AREDN list, like the Mesh Chat 2.13, which you have to get from another place. And I actually have that I got. Let's see. It should show up in here. There's the Mesh Chat 2.13 all IPK. And so I had to go download that from a different site because Mesh Chat was not in the AREDN repository. Okay. So I can do that. I downloaded that to my laptop and then I uploaded it through this mechanism.
What's the difference between that and what you can download through?
The difference is AREDN builds these for the different hardware platforms that they support. A lot of the other ones, you'll have to either find the one that's specific to your platform or find one that's written in Lua that is, doesn't care what platform it's running on. So that's the basic difference, is that these guys are ones that they have selected as being useful at the system level. And so they actually build these.
When we all configured these back October-ish, we put Mesh Chat on several of them. How is that different than what you downloaded?
So the new version of Mesh Chat, the 2.13 version. So the older version of the system with the old UI and everything, all of the back-end parts of it were written in Perl. And the front end was all this really simple web interface. The new version doesn't use Perl anymore. It uses a much lighter weight programming language called Lua. And so all of the back end stuff has been rewritten in Lua. And that version of Mesh Chat, the 2.13 version, is written in Lua. So you don't need a Perl interpreter to run that. The original Mesh Chat is still written in Perl, and you could run that on your laptop, for example, and it'll work. And it'll tie into if your laptop is on the LAN port of your router at home, you would be able to run Mesh Chat directly on your laptop and tie into the Mesh Chat that's running on the mesh. So we'll talk about that more when we talk about applications on the mesh, but but that's basically the idea there. And then again, we have our advanced options here, and we can say where to go to download those packages from, just like we did on the firmware page. Okay. So if I had a local mirror of the firmware of the packages downloads on the mesh, I could put the URL in here and not have to go out on the WAN to get to it.
You have to have the tunnel enabled to do that?
If you are accessing a repo that's on the mesh, you don't need the tunnel.
Well, what do you do?
If you have your WAN port on your network connected and you can get out to the internet, then you can access it that way. And that's what that default URL is. It's just out on the internet. It has to be attached to the WAN network port. So on the HAP, it's like port 1 is the WAN port. So that would be the one that you connect to your home network. Okay. So now it's also, you see here, it says I have 5 installed packages now instead of 3, which I had before, because it installed the live PCAP and the TCP dump. So those are network test tools that you might need at some point. On this network interface, I can go in here. Here's where I could see the mesh address of my node. I can change that LAN here. And again, remember we talked about how I might want the /29 as the default. That's the 5 hosts, really 6 hosts, but 1 is used by the node itself. I have this one set at 28, so I have 13 hosts available. You can set it at a /27, which gives you 29 hosts, or you can set it as a /30, which gives you only 1 host. You can also use 44net. Is anybody familiar with 44net? So back in the early days of the internet, remember we have this net 10 that is for disconnected stuff. And then there are other networks out there that start with different numbers, right? The net that starts with 44 is actually owned and operated by the ARDC, and it is specifically for ham radio use. And so back in the old packet radio days, people could get a 44net IP address and run IP over packet and access things on the internet through their packet network. You can also do that with AREDN if you want to use 44net.
Is that what like the university used when they started it?
Yeah, well, they used the original ARPANET originally there at the university, but yeah, it's a similar type of thing, right? It's another network.
Yeah.
The cool thing about 44net is it's a worldwide network. It's all tunneled together and stuff, so you can access services that are running on 44net if you are hooked up to it. You do have to request an allocation and an address on 44net, a subnet on 44net from ARDC. They give them away for free. They don't charge you for them. So you can do that if you want to. And then the other option here is NAT, which stands for Network Address Translation. And basically, if you set it to NAT, then the things that you have on the LAN will be able to access the mesh, but to the mesh, they'll look like they're coming from the node itself, not from the machines out on your LAN. And the things out on the mesh won't be able to reach your things on the LAN because they won't have routable IPs on your LAN. It'll go through the NAT connections. Just like at your house, your router at home connected to the internet, you only have one IP address from your internet service provider. And all of your stuff in your house, your TVs, your phone, your tablet, your laptops, whatever you've got at home, all connect to this router internally, and it maps or it translates all of them down to the one IP address that is known to the internet. It does know how to bring things back to you, so you could still access services through that, but you can't make a direct connection to that from the outside without it starting on the inside first. Okay, so that's what NAT is for. And then on your WAN mode, you can set up. So this WAN is your port that is connected to your home network and thus to the internet. And you can tell it to either use DHCP to set that up or to use a static IP address to set that up. And you can turn it off if you don't have a WAN connection. Okay. On devices like the HAP that have multiple ports, one of them will be designated as the WAN port. On devices like the LDF5 that only have one port, it'll use a particular VLAN for the WAN port. I think it's VLAN 1 for the WAN port and VLAN 2 for the DTD port. And then untagged traffic will be on the LAN. So that's what's going on there. And normally you're going to want to set it to DHCP because you're going to want your home router to give it an IP address. But if you have a special situation where you're using static IPs or you want to use a static IP for some reason, you can do that through this mechanism. And then here you can tell it what to use for DNS servers out on the internet. And again, we have an advanced options here where we can turn on or off levels of connectivity. So here I can say, I want my VLAN for WAN to be something. Now, if I went to this on my LDF5, this would be VLAN 1. But because this is my HAP and it has 5 ports, port 1 is always the WAN, so it's untagged. Okay. This mesh to WAN knob, if I have this turned on, then anything out on the net can access the internet through my node. Anything out on the mesh can access the internet through my node. You probably don't want that most of the time. I turned it on specifically when I want to update my nodes and I want them to be able to get out to the WAN to do that. It's on right now because I must have left it on last time I was playing with it. So I'm going to go ahead and turn that off. This LAN to WAN does the same thing. It says anything that's on my LAN can connect to the internet through my WAN port. I'm going to leave that on because that's okay for me. I don't care if it does that or not. And then this says LAN to mesh WAN. If somebody out there on the mesh has a WAN port that's connected and I have this turned on, then things on my LAN can access the internet through their node, not through my node, but through their node. And then LAN to 44net is the same kind of thing, but for 44net access. And then LAN default route basically says, normally the default route is going to just tell, it's just going to depend on the fact that the nodes on the LAN are on the mesh network. They have mesh IP addresses. If I turn this on, it'll actually give them a route. So they'll be able to use that route to direct traffic more effectively. Normally you don't need that. It's not something that's necessary, but in special cases, you might want that for certain purposes. Again, I can turn the help on and it'll tell me all about what each of these things do, right? So since I turned that mesh to WAN off, I have a change that I need to commit. I'm not going to do it right now, but I'll just leave that there for now. If I decided I didn't want to do that after all, I could just hit revert and it would go back to the way it was. All right, let's see. What else do I need to show on here? Internal services. So the AREDN firmware itself has a bunch of services on it. So if we look at this, you can see these services are things that are known to it to be able to turn on or off. Cloud Mesh basically says if there are any supernodes on my mesh, use them to access the supernet. Okay. The iPerf3 server, iPerf3 is a network performance tool. I can use that to compare the performance or the speed of traffic between any 2 nodes on the net, on the mesh. Remote logging, I have this turned on, so it's actually sending syslog information to my Raspberry Pi at home on my home network. And it does that using the UDP protocol. And this is the IP address of my Raspberry Pi and the port number where it's at, the syslog server on there.
Are you running our syslog?
So on that machine, I'm running, I think it's syslog NG, but it uses the syslog protocol. So there's a network protocol called syslog, and it uses port 514. is both UDP and TCP versions of it. I'm telling it to use the UDP version for this. So anytime an event happens that would get logged to a log file on my system, it will get sent to this log server. And I can log into that log server and go look at the logs that are specifically from this host. So I can see the logs from the local host and any other things that are sending logs to that host through my log server there. I don't want to log all of that locally because there's limited space on the nodes. My Pi has tons of space on it, so I don't have a problem logging to that. The WAN SSH basically says, allow me to SSH into the node from the WAN interface. Remember, the WAN interface is on my home network. So when I'm on my home network at home, I can SSH to the node from my home network. I don't have to get on the LAN. And then WAN telnet basically says allow telnet access to the node from the WAN interface. So the SSH is that protocol that we talked about before, where it uses a key exchange to log me in, or I can use the password. Telnet is unencrypted. So if I'm doing this to a node that's on the mesh and I'm using RF and I'm an amateur radio operator, I need to use Telnet, not SSH, because I don't want to be encrypting my traffic on the RF, right? Encryption is bad according to the FCC, so at least for us. And then WAN web allows web nodes to access to the node from the WAN interface, which basically is what I'm using to show you this interface that I'm using here. If I had this node sitting somewhere where it had a direct connection to the internet, in other words, it was on a internet connection, not my home network, I would turn these off because I don't want people monkeying around with it from the internet side. This is essentially my firewall, right? What I'm doing is I'm trusting my node at home to firewall these off. I can turn them off directly on the AREDN node itself. The hardware watchdog basically says if I turn this on, it'll use a mechanism where if the node freezes up or locks up for some reason, it will automatically reset. There's a hardware capability in there that says if a particular file doesn't get touched periodically, it will reboot the node. And that's a hardware thing. It's not something that's dependent on software. So if the software locked up and froze, it would reboot. I have that turned off. Well, this wireless watchdog does the same thing and lets it restart the Wi-Fi if the Wi-Fi connection goes away. So I have a machine at home. It's a Innovato Quadro that has the ham clock on it. And it does not behave very well if the Wi-Fi connection goes away and then comes back. And so it causes all kinds of grief. And I have to discover that it's broken and then go reset it when that happens. This node, because of this feature, will actually do that automatically. If the network goes away and comes back, it'll figure it out and do the right thing. I can also set it to automatically reboot at 3 a.m. every day if I want. Let's see, or I can put a different time in there and it'll automatically reboot at that time. Wireless Watchdog LQM will also restart the link quality monitor as part of the Wireless Watchdog. So that's the thing that is watching how well it's able to talk to other nodes. And if that link quality gets really bad, it'll reset the wireless. Okay. PoE pass-through allows me to turn on or off that PoE port on the HAP. I can turn the power off and then back on again and physically reboot my LDF5 that's connected to that via PoE without having to go outside and unplug it or something like that, right? I have the ability to do that through this interface. If I had a device plugged in there that didn't use PoE, I would turn this off and it wouldn't even try to send PoE out that port. And then if this device had a USB port on it, which it does not, I could turn USB power on or off. So like with Jeff's GPS that's plugged into his HAP on the USB port, he could power cycle that GPS by turning the USB power off and on again. Message updates. This basically, there's a server that if a message is present on that server, it will display it on the top of my interface. So when I go to my node, I'll see this bar across the top that has this message until I acknowledge it. It just says here, go look for a new one every hour. I can turn that off if I don't want it doing that. And then I can set a local message source if I want to use a different one other than the default AREDN one. They'll usually put things in there about new versions, new releases that are coming out or something like that. That's about the only time I've ever seen anything there. And then message groups, I can subscribe to a specific message group that is associated with that. So I'd have to know what the group names are. I don't know what they are. But that's basically the internal services that are on here. And you will see also on this page which ones are enabled, which ones are active, which ones are disabled or inactive, right? So I'm not running a supernode, so my supernode is disabled. I'm not running the hardware watchdog, so that's disabled. Local services. Here is where if I had like a phone attached to this node or a camera or something like that, I would add it in here. And so I have a list of things that it knows about how to set up already. And for example, when I set up the mesh chat, I just said, I want a mesh chat, and then I hit plus, and that now shows up here as a new service called mesh chat. It's a chat service. This is how you would get to it. And if I committed this, it would be there. And it can run side by side with the other one as long as it's on a different port.
Well, if you're setting up the chat, then you call other people to join you, or how does that work?
So the way it works is this part of the mesh chat name, like here I have SLCO. Anybody that's on my local mesh with SLCO will automatically communicate with me. So it'll show up in the interface.
Oh,
If they're on a different one, I won't see it on this one. This one would be like a generic one that doesn't have a separate zone name.
So
so how would people know?
They can see it on that
Okay.
interface, right? We'll go back and look at that for a second. Let me cancel
so
this.
let's say, Salt Lake County, which we set up,
Right.
Murray wants to have their own.
We could set up our own and run both.
And you could just have all of those.
Yeah.
That you were a part of,
Yeah.
let's say, in each of those. Okay.
Yeah. So if I go back here, remember this, was it this interface here? I can see like, here's a mesh chat Salt Lake County on Sam's node. Here's one called mesh chat 7489 on N7KRJ's node. So that's not going to see the Salt Lake County stuff. It's its own separate thing. Let's see if there's another one on here. Here's another Salt Lake County on W7PKA's node.
No one right next to that one.
And then, yeah, there's another one right there. And here's another one that's on mesh chat 766. It's by itself. So if I went to this node, I could go to this mesh chat on that node and use it, but it would stay local to that node because there aren't any other 766s out there.
He knows he's got two up there. He's got dish and then there's standard LB1.
Yeah. He's got two devices. He's only running the mesh chat on this one. All right. All right, let's go back to where we were a second ago. Status page. Okay, so we were looking at services. So if I was going to add a phone, for example, I could put it here. And then when I hit the plus, I can put my IP address of my phone, which would be my extension, or if I had it connected to a PBX, I would have an extension number associated with that PBX. PBX is a private branch exchange. It's like a phone server, you can think of it as being. So my phones, I could have a bunch of phones connected to the same PBX, and then I could call by just dialing an extension number rather than having to know the IP address of the phone. A lot of people are putting their IP address in here because we're not running a PBX right now. And I can name that phone something. By default, it's going to be the node name, but I could change it to Jan's phone or something like that. And that will show up in that interface where the phone is listed. You can change the little icon that shows up next to those guys. So if I wanted to change it to something other than a phone, I could do that. Although that would really confuse people. So that's the weather one is for connecting to a weather service. And so you can actually have like a weather station attached.
Okay, so that
To
guy
this.
station at home would be dedicated just for that thing?
It doesn't have to be. I mean, you can run multiple services on
It's like right now, mine's up on the underground.
Weather Underground. Yeah.
So I can still connect it up to that thing?
I don't know if you can do that. We'd have to play around with it and figure out if we can access it simultaneously. Because your weather station is reaching out to Weather Underground to upload information. This, I think, is going to have it asking your weather station directly for information. The only one that they listed here is WeWX, which I don't know anything about WeWX weather stations, but I could always, if I can access it through a web interface, I could always just use a generic HTTP interface or connection type for that. And then I could change the icon to the weather icon if I had, if it was a weather station. WinLink Post Office is another one that's kind of cool. You can actually set up a WinLink post office, and if you've got a WinLink client on the mesh, it will automatically find that and offer you to connect to that over the mesh when you do a telnet connection. So it's still going over RF, it's just going over the mesh RF instead of HF or VHF or whatever. And you can run a WinLink post office and access an RMS that's on the mesh through the mesh, which is kind of cool. But there's a ton of different things in here, like a camera. There's a few different cameras that are supported. If your camera isn't supported or isn't directly supported, you may get away with using the generic HTTP, and you just have to put in the URL to get to the camera. Like if I was to put my Innovato on here, I don't see there's an NTP server I could set, but I could also put in a generic HTTP interface for the web view of the clock. If you guys have never seen one of those, it looks like this. I gotta go to. Oh, I'll have to show you after I disconnect because I have the socks connected up right now.
But if I plug my camera system directly in.
You could, yeah.
Well, yes and no. I've got a Reolink camera. And just because it says Reolink camera there.
It doesn't necessarily work.
automatically.
Okay. Well, again, we may have to play with that a little bit and see what we can figure out. Because I don't know what's different about the Reolink camera. I'm assuming it's just pre-populated this part of the URL for that.
Without any like a camera router system that's already up and running.
Yeah, that you could access that through an interface.
See all 16 cameras.
Yeah, you could do that with the generic HTTP and then just change this to camera, right? Or video or something like that. Camera probably. Yeah. So, like I say, there's a ton of different.
IP address.
You'd have to find the IP address that it's using.
Same thing.
So they have a bunch of different canned recipes in here, but you can always use generic URL and put it in yourself, right? So, and you just have to specify how to get to it, whether it's HTTP or FTP or Telnet or whatever, right? And then a port and a path to get to it. This would be the address of it right here. So.
Now, if you have a single camera,
Do you have to do the phone service?
No, you don't. You don't have to do that. It's only if you want to publicize it. You could have the device attached to your thing and not define it as a local service. and it'll still work. You can still make calls, and people who know your IP can receive calls. It's just this will publish it into that list of known services on the mesh. Okay. So if you want other people to be able to find you without already knowing who you are, then you probably want to set it up this way. If you don't, then don't do that, right?
Oh, as long as they don't get any sales.
Yeah, well, I don't. If anybody tries to sell you anything over that, just tell them, hey, the FCC says no, 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 and there's a $10,000 fine. So,
Unless it's ham radio stuff.
unless it's ham radio stuff, right? So there's a whole bunch of different things you can do here. You can basically add your own services. You can add your own aliases to different host names as well. So if I had right now, this guy is my LDF5, and it's going to be KD7ZW-1, but I could change it to my dish or something like that, and that name would also exist on the mesh, and I could access it through that. And then port forwarding, this is basically saying I want to forward these services from the WAN to the LAN. So if I had if I moved my Innovato onto the LAN port of my HAP, I could still access it from home if I put a port forward in to do that from my home network. I just would be accessing it through this mechanism instead of directly. So if I choose to do that at some point, which I've been thinking about putting it on there just for fun. These kinds of things, have to happen, right? So yeah, so there is the ability to do specific port forwards in and out as you desire. But yeah, so it's pretty straightforward once you get in there and see how that works. Local devices, again, this would be if I had a physical device connected here, it would show up on here. And then local nodes, again, this would be if the tunnel was working, I could click on this and go directly to my LDF5, or I could go to Sam's node. And it's already after 8. So what we're probably going to have to do is stop here. And then next month, we'll come back in and we'll pick up with radio services and how to change things in there. And hopefully I will have the tunnel working by then, and we can go look at some of these other things that we've been talking about tonight.
Hey, Jan,
Oh yeah, go ahead.
just a quick note about that hardware watchdog. Would you turn that on if you were leaving a node unattended at some remote
Yes,
location?
I would definitely consider turning it on in that case, because the chances of it locking up on you are pretty slim. But if it does, and it's, on top of a high mountain or something, you probably don't want to have to find a way to get there in the middle of a snowstorm, right? So I would definitely consider turning it on in that case. I don't usually bother to turn it on my stuff because it's sitting on my desk right at home. So I don't care if it locks up. I'll just go reset it. But it's
Okay,
basically a little automation around that.
To extend the example a little bit, though, if it's sitting on your desk at home and you've put it on the mesh and other people are counting on it while you're away at work.
Well, that's too bad for them. If it goes down and I'm at home, I'm not at home. I mean, I can access it from like I'm accessing it right now. I can do that. So if I can get into it and reboot it, I could do that. Or I could always call my son and say, "Hey, go downstairs and power cycle that box that's sitting on the desk," right? So
Okay,
that
so what is the downside to having it on if it's just sitting on your desk?
there's really no downside. I mean, I could turn it on. It would be fine.
Okay, I just wondered because uh I know, for example, I've got a couple repeater controllers that have watchdog timers in them that'll
Right.
reboot the hardware if it doesn't get a tick every so often and that kind of thing. I just wondered if there was some security issue with it, or
No, not really.
if it could behave unpredictably or what.
Um, the only issue would be is if the watchdog got confused and decided to reboot the node while you were in the middle of doing something, that could be annoying. But in general, I don't think there's any reason why you couldn't turn it on at any time.
Okay, well, given the AREDN team's demonstrated expertise at anticipating everything that could go wrong. I have no qualms.
Yes, exactly. Because we are so great at that. And so are the AREDN guys who write this stuff. They plan for every eventuality except wanting to run a tunnel from your laptop into a node, which doesn't work. So anyway, we'll hopefully in the next 4 weeks, I'll have time to figure out how to make that work. And we'll be able to pick this up and do some cool stuff with it at that point. But yeah, we'll probably have to quit right now because it is 10 after 8. And I told my wife I'd be home by 8:30. So I'm gonna have to wrap it up. I don't have that far to go. I'm only about a mile from home, but still. Anyway, I appreciate everybody coming. I'm gonna go ahead and stop the recording at this point, and we'll end the recording.